Solve the following system of equations. Write your answer as an ordered pair. Okay, in the past, what we would do is we would take our second equation, this guy right here, negative 2x plus 4y equals negative 10, and we would convert that guy to slope-intercept form so we could graph it down there. So this is the equation for this line in slope-intercept form. Here is the graph of that equation. Then we would graph our second equation, this guy, and we would do that by putting a point on the y-intercept, and because there's no x, we know it's a horizontal line that goes through negative 2, and we would look at where they intersected. Here it is at point 1 comma negative 2. That would be our solution to this system of equations, and we had in the past found that solution by graphing both lines. Today, what we're going to learn is another way that we can solve systems of equations, and that method is called substitution. We don't need a graph to do substitution. It's actually pretty intuitive. It's in the name. We substitute. So we know that y equals 2. So we want to know, or this equation is y equals negative 2. We want to know what is the value of x and y when this equation is equal to this equation. Simply, all we're going to do is we know that y is negative 2, and because y is negative 2, y and negative 2 are interchangeable. We can take our negative 2 and in our second equation, take out the y, put in that negative 2. Now this should be looking familiar. Draw a river and solve for x. 4 times negative 2, and that'll get us negative 8, and we just carry down the negative 2x and the negative 10. And after that, we're just going to get x by itself. So I'm going to add positive 8 to both sides to get rid of the negative 8. And x equals positive 1 will be my result. This positive 1 was the x-coordinate of my solution. This negative 2 was the y-coordinate of my solution. Problem 2. Now you try it. Alright, so for here, we're going to do the same exact thing as we did in the other one. We're going to take our equation, y equals 7, and we're going to evaluate this equation when y is equal to 7. So we're going to replace the y with what this equation says that y is equal to. We're going to replace that y with 7. Multiply. Get rid of the 21 that's being added to our term with x. Divide both sides by 4. X will come out to be negative 5, which means that the x-coordinate to this point is negative 5, and the y-coordinate is positive 7. That's our solution to that system of equations. That is where this line, y equals 7, and this line, 4x plus 3y equals 1, will intersect. Problem 3. Alright, same logic applies when we have not just y equals a number, but when we have y equals an equation. Here in problem 3 and problem 2, we were looking at a horizontal line and where that intersected with a sloped line. And now we're going to be looking at where does a sloped line intersect with another sloped line. Here, if I were to convert this into slope-intercept form and graph both lines, these two lines would intersect at 8, negative 2. That would be my solution to this system of equations. But there's a different way for us to find it. We can find it using substitution. So I wrote my original equations up here so I can reference them and know where my stuff came from. And now here I know that y is equal to, or y is negative 2x plus 14. Negative 2x plus 14 is the same exact thing as y. Because negative 2x plus 14 is the same exact thing as y, I can find out where these two equations are going to meet, or where they're going to equal each other, by just taking out the y, kicking him out, and replacing that y with what the other equation said y was equal to, which is negative 2x plus 14. In other words, I took this, negative 2x plus 14, and I stuck it in for y. Now I'm just going to solve for x. So here, from this step to this step, all I did was change my subtraction to plus negative. Now I'm just going to solve for x. First thing, got to take care of this set of parentheses. Carry down my negative 5x. Then negative 8 times negative 2 is positive 16x. Plus negative 8 times 14, which is going to be negative 112, is equal to negative 24. I'm going to combine some like terms. Going to get rid of my negative 112. Now I have 11x equals 88. I want 1x, so divide both sides by 11. X equals 8, which means that the x coordinate of the point where these two guys meet is going to be 8. Now I got to solve for the y coordinate. So I'm just going to pick one of my original equations. This one's going to be my easiest one to pick. But I could have done either, it doesn't matter. And I'm going to plug in the 8 for x. So I found that x is equal to 8, and I'm going to see what y is, what the y coordinate of my point is when the x coordinate is 8. So I'll put this over here so I can do the work. And take out the x, put in the 8, and then I'm just going to solve for y. Negative 2 times 8 is going to give me negative 16. Negative 16 plus 14 gives me negative 2, and voila. I find my y coordinate of my point through substitution. I found my x coordinate of my point through substitution. I'm finding the exact same thing that I did when I was graphing. All right, problem 4. Solve the following system of equations. Write your answer as an ordered pair. Okay, so we've got 6x plus 2y equals 24, and y equals 4x minus 2. We're going to find this using substitution. Now, notice over here I wrote a blank ordered pair. This is so I don't forget to find both coordinates. And I don't forget, like once I find my x coordinate, I don't get super excited and think I'm done. I remember that I also need to find my y coordinate. So I write this ahead of time every time I solve a system of equations. All right, so let's get started. First thing I'm going to do is I have these two equations. This equation is telling me that 6x plus 2 times whatever y is equal to 24. This equation is telling me that y is 4x minus 2. I want to find out where these two equations are equal. Where do they cross? Because this equation is telling me that y is 4x minus 2. I can take my my y in this equation and I put it in parentheses, and then I just give him the boot and I substitute it with the expression that y was equal to in my other equation. I substitute it with 4x minus 2. So essentially all I did was that. Once I have that done, I'm going to draw my river, and I'm going to solve for x. Take care of that multiplication, and I'm going to get 6x, carry down my 6, plus 8x plus negative 4 is equal to 24. Combine like terms. Add 4 to each side to get rid of the negative 4. Divide each side by 14. Get x equals 2. Then what I'm going to do is I'm going to take my x equals 2. I'm going to put it into my ordered pair. Right there. Now I know that I'm not done yet. Got to solve for y. I'm going to pick an original equation, plug in the 2, and solve for y. Merp. 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 4 times 2 is 8. 8 plus negative 2 is 6. Take my 6, put it in for y. That's my solution. Try this one on your own.